Somewhere 16 billion miles from Earth, a machine built in 1977 is humming. Not literally, but scientifically, and NASA has the recording to prove it. Voyager 1 picked up a sound that shouldn't exist in the emptiness of interstellar space, and when engineers translated that signal into audio, what they heard left them without a clean explanation. This isn't a rumor, it's a confirmed part of the mission record. And it's only the beginning of a much stranger story. Give me a few minutes here because this is one of those cases where a real documented NASA finding somehow sounds stranger than fiction. By the end, you'll understand exactly why scientists still can't fully explain what Voyager 1 is flying through, even after more than a decade of studying it. Here's the sound in question. Back in 2013, using its plasma wave instrument, Voyager 1 detected a persistent low vibration running through the ionized gas surrounding it. NASA converted that electromagnetic data into audio, and what came back was described almost like a steady hum, a tone rippling continuously through what was supposed to be quiet, empty interstellar space. It wasn't static, it wasn't a malfunction, it was the sound of the interstellar medium itself, vibrating in a way nobody had ever recorded before, because nothing built by humans had ever physically been out there to listen. That discovery alone rewrote assumptions about what the space between stars actually looks like and sounds like at the most fundamental level. But it turned out to be just the first thread in a much bigger mystery, one NASA has continued confirming piece by piece for over a decade. If you're new here, we cover confirmed space discoveries like this every single week. So go ahead and subscribe before we continue. Because what happened after that hum was detected is where this story becomes genuinely hard to explain. To understand why this hum mattered so much, you need to understand where Voyager 1 actually was when it recorded it. In 2012, the spacecraft crossed a boundary called the heliopause, the invisible edge where the sun's constant stream of charged particles finally loses its strength against the pressure of the wider galaxy. Crossing that line meant Voyager 1 had left the neighborhood of our sun entirely. It became the first human-made object in history to reach true interstellar space. Scientists expected that once Voyager 1 crossed that boundary, conditions would simplify into a calm, predictable environment. Instead, the opposite happened. Cosmic ray intensity jumped. Plasma waves revealed constant, unexpected activity, and the direction of the magnetic field surrounding the spacecraft was measured at roughly 40 degrees off from where researchers expected true interstellar space to align. That's not a small discrepancy. That's a sign the outer boundary of our solar system doesn't behave like a clean, simple wall. It behaves more like a twisted, shifting frontier that current models still struggle to fully describe. Then, in 2020, NASA confirmed something even stranger. Voyager 1's magnetometer recorded a sudden, sustained spike in magnetic intensity, and at the same time, its plasma detector picked up a matching surge in particle density. This wasn't a brief spike lasting a few hours. It lasted for months, and researchers are still analyzing its full implications in papers published as recently as this year. One leading theory ties this event back to our own sun. A massive burst of solar material, ejected years earlier during a period of intense solar activity, may have finally caught up to Voyager 1 and rippled outward through the interstellar medium, compressing plasma and intensifying the magnetic field far beyond where scientists thought solar influence could reach. If that theory holds, it means the sun's fingerprints stretch much farther into deep space than anyone previously calculated. But other researchers disagree, arguing the pattern of the disturbance didn't cleanly match known solar activity, and that Voyager 1 may have entered a genuinely new, undisturbed region of interstellar space instead, one with its own independent and unexplained behavior. NASA has not picked a side in this debate. Both explanations remain officially on the table, actively discussed in current research. And that uncertainty, coming directly from the agency running the mission, is exactly what makes the story different from typical internet speculation. This isn't an unverified claim floating around social media. It's a real, unresolved scientific question, confirmed by the people who built and still operate the spacecraft. What makes resolving this debate so difficult is that Voyager 1 has no backup out there with it. There is no second spacecraft parked nearby to double-check its readings against. Voyager 2 is following an entirely different trajectory, years away from reaching the same distance in the same strange pocket of space. That means every anomaly Voyager 1 records has to be verified using nothing but repeated measurements from the same aging instruments, gathered over years, with no independent source to confirm whether a given signal is a permanent feature of this environment or a temporary passing event. Here's where the story takes an even more dramatic turn, because confirming these mysteries has come at a serious cost. Voyager 1 is running out of power, and NASA has had to make difficult calculated sacrifices just to keep the mission alive, long enough to keep studying them. Both Voyager probes run on radioisotope thermoelectric generators, devices that convert heat from slowly decaying plutonium into usable electricity. That power source has In April of 2026, NASA sent a command permanently deactivating Voyager 1's Low Energy Charged Particles instrument, a tool that had operated almost continuously since the spacecraft launched nearly 50 years earlier. Its twin, Voyager 2, had already lost the same instrument the year before. Today, only a small handful of Voyager 1's original 10 science instruments remain active, just enough to keep recording the very anomalies that continue to puzzle researchers. And this is where NASA's confirmation gets genuinely remarkable. Rather than quietly accepting the spacecraft's slow shutdown, engineers have been developing an ambitious plan, internally nicknamed the Big Bang Fix, designed to squeeze more operational life out of Voyager 1 than anyone expected possible. The approach is being tested first on Voyager 2, which currently has slightly more available power to work with, using new power management techniques that could allow previously deactivated systems to be safely brought back online. If the test succeeds, NASA hopes to apply the same fix to Voyager 1 itself. Nobody at NASA is promising this will work. But the fact that engineers are actively racing to revive a fading, nearly 50-year-old spacecraft, purely to keep collecting data on a mystery they still can't fully explain, tells you everything about how seriously this is being treated inside the agency. Consider just how difficult that engineering effort actually is. Every single command sent to Voyager 1 has to travel nearly a full day before it even arrives. And any confirmation that it worked takes another full day to come back. There's no room for quick trial and error the way engineers might work on a spacecraft closer to Earth. And because Voyager 1 still runs on software and hardware conventions from the 1970s, long before most modern engineers were even born, keeping this fix on track requires knowledge passed down carefully from an earlier generation of NASA specialists, many of whom have already retired. Layered on top of all this is a milestone NASA recently confirmed that sounds almost impossible on its own. In November of 2026, Voyager 1 will officially become the first human-made object to reach a distance of 1 full light day from Earth, just over 16 billion miles. At that distance, a radio signal sent from Earth, moving at the fastest speed physically possible in the universe, will take a full 24 hours just to reach the spacecraft, and another full day for any reply to make its way back. Arrive until Wednesday. 2 full days just to say hello and hear an answer back. No human-made object has ever operated in active two-way communication at a distance this extreme. Put all of these confirmed pieces together, and you get a genuinely strange picture. A spacecraft recording an unexplained ambient hum through interstellar plasma. A magnetic field bent nearly 40 degrees off from expectations. A months-long magnetic and density surge that scientists still can't fully agree on the cause of. A dying power supply, forcing engineers into a desperate, ambitious rescue plan. And a communication delay, about to stretch to a full 48-hour round trip, just as all of this continues unfolding in real time. Some online headlines have taken these confirmed facts and stretched them into far more dramatic claims than NASA has ever actually made. The real, documented reality doesn't need exaggeration to be fascinating. NASA's own language describes unexpected changes in particle density, magnetic field direction, and cosmic radiation levels, changes that continue to challenge and reshape scientists' understanding of the region beyond our solar system. That's a direct reflection of where the confirmed science actually stands.